Hi, this tutorial is going to show you how to take Ubuntu Server 14.04 and configure it as a router. Um, what I've done here at my own home for my network is I've taken a small PC that has a dual-core processor, 3 gigs of RAM, and I've turned that into my gateway for my home network. Well, in any network you need to have something to route um, your addresses for your network, and I've also configured mine to act as a DNS server, so all my machines on the network can have their own host name, as well as configured it as my main firewall using iptables. Now this setup that I'm going to show you today is going to be configured to use Webmin. It's a GUI interface that you can log into remotely, which allows you to set up all your DHCP services, assign all your IP addresses, configure your Bind9 server, as well as control your firewall. And you can view logs, and there's just a whole lot of stuff that you can do with it that gives you a lot more powerful front end to your network, and I believe it's a lot more secure as well. So we're going to start off. I'm just going to run through a quick install of Ubuntu Server. At this point, this should be the first thing that you see whenever you boot your machine from the CD. You will probably have to download the 64-bit 14.04 Ubuntu Server from their website and burn the ISO to a CD. And then you would have to configure your BIOS to boot from that CD drive in order to get to this point. So the first thing it's asking is for language. We'll go ahead and select English, and then we're going to install Ubuntu Server. Okay, and the next screen, of course, is asking for your language again. We'll pick English, and I'm in the United States. And if you want to allow it, if you're from another country and you have a different keyboard layout, you can allow it to detect. I'm going to hit no so I can pick mine manually. I do have an English US keyboard, English US. Okay, it's just loading components for the install, and depending on the processor and amount of RAM you have in your machine, this could take longer. It may not take quite as long. It should detect your network interface. Let's talk about that for a second. In order for your machine to become a router, you're going to need to have 2 network cards, one to serve as your WAN for your wide area network, which would be your connection coming in from your ISP, and then the secondary interface would be configured as your LAN, so that would be the local area network that goes out to either your switch or a computer on your network, however you have things set up. So here it is asking for a host name for the system. Now this is not including your domain name. If you have a domain like me that I have purchased to use for my home network, the reason that I purchased one was so I could configure websites or web interfaces such as OwnCloud or a postfix Dovecot mail server, things of that nature that I'm going to need a domain that is resolved to my public facing IP address. So say I'm away from home, or if I'm using mail services, whenever that domain is accessed on the web, it will be routed through DNS to my external IP address, which would then hit my DNS server locally, which would resolve and tell it which machine to go to get to those services. But this is just going to be a host name, so let's call it router, and you can name it whatever you like, and hit enter. And it's asking you for a user. Just for this tutorial, we'll go ahead and use router as well, and we'll use router as the username. Now remember, this username is going to be the same name that you use to log into your router with, and you can name that whatever you wish, and then it's going to ask for a password for that user, and then you need to verify. Okay, it's telling you here, and just for this tutorial I've used a very simple password. This being a server edition, it's telling you that it's a weak password, and it's asking if you want to use it. I wouldn't recommend using a weak password, but just for ease of this tutorial, I'm going to go ahead and say yes, let's use that. Now if you want to encrypt your home directory, you can. If you're going to be storing personal files and things like that in your home directory on the server, you may want to encrypt that information, which just allows it to be decrypted whenever you log in with the correct username and password. But if somebody else tries to log in, or someone gains access to the server without that username and password, your files will be encrypted. This being a router, I don't serve or hold any files on it, so I'm just going to say no to encryption. It is setting up the network clock. Pick your time zone. Okay, if you're familiar with disk partitioning and you want to create partitions for different things on your router, that's fine, you can do that. Again, this machine, the way I would be using it would be solely dedicated as a router. I believe it's better security to keep as minimal amounts of software and services running on your router as possible, because you want it to be secure. So I'm just going to go ahead and pick guided to use the entire disk, and that is my disk that I have. I will select that one, and it's asking if you want to write the changes to the disk, and we'll check yes. Now it will install the system. Okay, then it will ask you if you have an HTTP proxy. You can enter that information in here. With the Ubuntu server, you can actually install a squid proxy if you want to use caching for your local network and things, but at this point we don't have an HT proxy, so we'll leave that blank and hit continue. Now it's configuring apt for software installation. Okay, now it is going through the select and install software process. Then it will come up and ask you how you want to configure updates. Some people say to not allow it to do automatic updates since it is a server, especially if you're in an enterprise environment and you want to test all your updates before they are deployed on a live network. You can select no automatic updates. Personally, myself, for home use, I like to at least install security updates automatically, so I will do that. And then it's going to present you with options here of software you can pre-install while installing your operating system. Keep in mind, any of these you can install at a later time. You don't have to install them right now. But since I want to be able to access my server remotely, I will at least choose the OpenSSH server. So I'll put the red block on that and hit the space bar to select it. If you want DNS server, LAMP, mail, any of that other stuff, you can. If you're going to set it up as a file server, you can select Samba package. But for now, all I'm going to install is OpenSSH. So I will hit continue. Okay, now it's installing the bootloader. If you are installing this on a machine that has another operating system on it, you want to be very careful about this. You would want to set up your bootloader a different way. In this case, this is just a machine dedicated as a router. This will be the only operating system installed on it. So we will go ahead and install the grub bootloader to the master boot record by selecting yes. And it's just finishing things up. It says the installation is complete, so now you want to reboot, and you will come up to a login prompt. So let's go ahead and reboot. And it will go ahead and boot into Ubuntu. Okay, once the boot process is complete, you will come up to a login prompt. Now, Ubuntu Server is strictly a command line interface OS. It does not have a GUI interface of any kind. All configuration and work is done via terminal using command line. So let's go ahead and log into our server. So we'll use the username and password credentials that we created during the install. So our username was router, and we'll enter our password. Okay, so now we are at the command line. Now remember, Ubuntu does not allow root login by default, so we're going to be using the sudo command, which will allow us to run commands as super user or essentially as root user. So now that we've got the Linux server installed, first thing that I like to do in this process is to go ahead and edit my sources list to include a repository for Webmin, because it's not included in the regular repositories. So in order to do that, we will sudo, and the editor, you can use either Vi or Nano or whatever you prefer. I like to use Nano, it's a little simpler. We'll go to etc apt, and the file we want to edit is sources.list, and then it will ask for your password for the sudo command. So we'll go ahead and scroll down to the bottom of this file, and we're going to add a line that's going to include our repository for Webmin. So we'll go ahead and add deb http://download.webmin.com/repository and sarge contrib. Okay, then we'll hit Control O to overwrite that file, hit enter, and then Control X to exit out of the editor. So we'll just clear that screen. Next we need to add our key for the Webmin repository. So we'll sudo wget key is located at www.webmin.com/jcameron-key.asc. That's the name of the key. We'll hit enter. So it shows that it downloaded it. If we want to make sure, we can just list our directory. I have 2 instances in there of it, but I was downloading it earlier just to test the repository, but we only need one. So let's go ahead and add the key. Sudo apt key add and the name of the key that we want to add. Hit enter. It says OK. It did add the key. So now we're going to update our repositories. Sudo apt-get update and hit enter. And it'll update our repository list to include the repository for Webmin that we just added. Okay. So now the next step is we want to install some software that's going to be required to create our router. So we're going to sudo apt-get install, and the packages we're going to install will be bind9. We'll install Perl, of course Webmin, and we need DHCP3 server, and we'll also install OpenSSL and hit enter. It's going to ask, is it okay? It's going to use disk space. Just say yes and continue. Okay, so all of our software is installed. Next thing, let's go ahead and edit our network interfaces. Those are located in the etc network directory. So we're going to use our nano editor, sudo nano, and we'll go to etc network, if I can spell, and interfaces is the file that we want to edit. Just hit enter. Okay, so you see right now it has the loopback interface configured, and it also has the primary network interface. So as we talked about earlier, we have 2 interface cards, one for our WAN and one for our LAN. The way that I have this one set up, ETH0 is my WAN, and I know this because it's the only interface up, and I was able to download software, so I know whichever interface card I am plugged into is ETH0. That's the one that's currently working. So what we want to do is we want to go ahead and add configuration for our ETH1, which is going to be our LAN interface. So first, let's come up here and we'll change this to WAN network interface. We know that's on DHCP, and we will comment out another line and call this LAN network interface. We'll come down to the next line, and we want this interface to be brought up whenever the server reboots. So we'll put in our auto ETH1, and we'll define our static line. That's interface ETH1, our LAN, inet static. We'll come down to the next line and hit tab, and here we're going to define our address for our LAN. This is going to be the IP address of your router. You can have that be anything you want: 10.10.0.1, 192.168.1.1.0.1, whatever you prefer. For this, I'm going to use 10. I'll use 10.1.10.1. That's going to be our router IP. Our net mask, we'll use just a regular 24-bit. Which states that the first three sections. The first 24 bits of our address are going to be the network address. The last section, where the .1 is, will allow us to assign IP addresses through .2 to 254. We're going to go ahead and make our broadcast address. That's going to be our network, and .255, that's the IP all broadcasts will be sent and received on. Our network, which is our subnet, is going to be 10.1.10.0. Now, whatever address you choose to use for your router, you will always use those first three. Now, if you want to create a wider subnet, say a /16 or /8 even, you can change those numbers. You would have even a wider range, but we're going to use a /24 subnet. That's plenty of addresses for a home network, I would think, unless you just have thousands of computers in your home, and I doubt that you do. So we'll go ahead and stick with the /24 subnet. Okay, so that should be all that we need to change in our interfaces file. So we'll go ahead and Control O to overwrite, enter, and Control X to exit. So now we need to enable IPv4 forwarding, which is going to allow your router to issue IP addresses to the computers on your network and to route. So we'll go ahead and edit our sysctl configuration file. So we'll sudo nano, and that is located in the etc directory sysctl.conf. So we'll hit enter, and all we need to do in this file is scroll down to where it says uncomment the next line to enable packet forwarding for IP version 4. So as you can see, the line down here is commented out, so we would just want to delete the £, and that's all we need to do in this file. If you need to configure anything else, you can. You probably already know all of what I'm showing you here if you're familiar enough to edit anything else, but let's go ahead and overwrite the file, Control O and Control X to exit out. Okay, so now that we have all that configured, let's go ahead and take a look at our interfaces to make sure that they're both online. So we'll run ifconfig. Okay, so we have ETH0, that's our WAN interface and our loopback interface, but we don't have ETH1 online. That is our LAN interface card. Of course, we're going to need that up in order for the router to do its job. So let's take a look at what interfaces are recognized by our system. So we'll run ifconfig-a. Okay, so we can see the card, but it's not up. It does not have our address that we assigned. So let's bring that online. We'll sudo if up eth1. So now our card is online. Let's take a look again to make sure. Okay, so it's online. It has our internet address, which is our router's IP, 10.1.10.1. Has a broadcast net mask. It is receiving and transmitting packets, so everything looks good. Okay, so now we're through here. Let's go ahead and take a look at our Webmin GUI interface, and I'll show you how to set up your subnet. Okay, so here we are in an instance of Ubuntu 14.04. This is the desktop version. So this is essentially another computer on the network. Keep in mind that it does need to be on the same subnet as your router. So if it's not, you can go into your interface settings and you can set it up. Like here, I've gone into the interfaces file and I've assigned it an address to use on that subnet. You can do that the same way as you did on the server. Okay, I need to put in nano if I want to be able to edit it. Okay, so I just went in here and assigned it a static address, same net mask broadcast. So it pulled from the router. So let's go ahead and exit out of that. Just wanted to show you how you can get on the same subnet. So Webmin uses the default port of 10,000. So we put in our router's IP address, and we're using HTTPS and colon port 10,000, and it comes up, says this is an untrusted connection. Just means this is a self-signed certificate. We are creating this router, so we definitely know that this connection is safe. So we'll click I understand. We'll add the exception, get the certificate, and confirm. So now we are at the Webmin login screen. So what we want to do is enter in the credentials that we used to create our server account. So that was router, and then our password we created. Since this is on a local machine, we can remember the login permanently if you wish, and click login. Okay, so here we have pretty nice looking web interface. It shows all your system information, how much RAM you're using, your disk space. You can actually get to your updates from here. Since I'm on the screen, let me go ahead and configure my time on the system, make sure I have the proper time zone. We'll go to change time zone, and I am in the central time zone, so that's good. We'll just hit save. You can go into that drop down and pick whatever time zone you need. Okay, so a couple of things that I like to do first on a fresh install of Webmin is I'll go into our configuration under ports and addresses, and you want saying here you can listen on which IP and which port. Right now it's set to listen on any address on the network and on port 10,000. So let's change this to only listen on the IP address of our router. Port 10,000 is fine. Okay, all the rest of this should be fine. We're not using IPv6, so we'll hit save. Okay, and then let's go back into configuration. We'll go into IP access control. First thing, we'll go ahead and include our local network in the list of our ACL. So, and then we're going to only allow from listed addresses. We're going to go ahead and put in the IP of the machine we're using, which is the .100. That's what we configured in the interfaces. We'll go ahead and resolve host names. This will create a little extra load on your server, but if you don't have very many machines, especially that are accessing Webmin, it's not going to make much difference. I do this because when I configure by9 my DNS server, I assign each IP address on my network a individual host name, such as laserjet.yourdomain.com, whatever it may be, or Windows 7 dot, just an identifier for each computer. That way when you're accessing network shares and doing NS lookups on your network to find which machine has which address, you can just type in that DNS name and it will show you the address. We'll get to that later, but let's go ahead and click save here. It's saying that it's restarting. Just to wait a few seconds. Okay, so we'll go ahead and click return. Okay, so for now I think we're good on the configuration. So first thing, let's go ahead and configure our DHCP server. So we'll go into our network configuration. Let's just take a look at our interfaces. These are both activated on boot. That all looks good. Okay, so now let's go into our DHCP server. One more thing here in our network configuration. Let's go to our host name and DNS client. Okay, so it shows here our host name of our server, but this is an important one here. Our DNS servers, this could be what's already going to be in there, could possibly be a DNS server for your ISP. Let's move that down a line. That's going to be our secondary. For our primary, let's put in the address for our router, because that's going to be our DNS server for the network. And we'll also put our search domain as the same IP address for that router. We'll go ahead and save that file, and we'll apply our configuration. Okay, so now let's go into our DHCP server, and we're going to go here to create a new subnet, because we need to add the subnet for our router to function properly. So we'll click on add new subnet. The description can be whatever you like. We'll call it Linux router. Okay, our network address, that's going to be our subnet. That will be our 10.1.10.0. Our net mask, 255.255.255.0. Now our address range, that is going to be whatever range we want the router to assign dynamically from DHCP. Say you have somebody that comes over, they want to connect to your network, they either plug in or access via wireless. You want them to be able to be assigned an IP address automatically without you having to go in and manually assign a MAC address and all that good stuff. So whatever address they receive is going to be within this range that you define here. Keep in mind, if you're assigning static addresses for all your local network machines like I do, you want this DHCP range to be outside, or rather any machine on your network that's statically assigned, you want it to be outside of your DHCP range. So you don't want any of the addresses you have statically assigned to be available for lease. So since .100 is the address that we gave this computer, we'll put our range from 200 to 209. So that'll give us 10 DHCP addresses that are up for lease. If you need more, you can just adjust that number, and you can change that at any time. It's not something that you have to set right this minute, or you'll lose out. So if you need to increase that number later, you can. Okay, so at this time there's really nothing else that we need to configure in here. You can change your default maximum lease times. It's set at default right now, but you can change it for a year or whatever you want. That's just going to limit the amount of time that a new lease is tried to be issued to whatever devices are connected. So, and that's done by seconds. So anyway, let's go ahead and create our subnet. Okay, so now that we have our subnet created, let's go back in there, and we're going to edit client options. And here we're going to need a few different things. We're going to need to put in our subnet mask, which was the 255.255.255.0. Our default router, that's going to be the IP address of our router. Again, our broadcast address, and our DNS server is also our router. So that should be all that we need to save. You can add a domain name if you have that. If you don't have a domain name, you don't have to add that right now. But let's go ahead and click Save, and then we'll click Save again. So now we want to come down here and edit our network interface. Here we want to pick whichever interface is being used as our LAN. This is going to be the network interface that issues IP addresses. Basically, it will be the interface that's listening for connections. So in our case, this is going to be ETH1. We'll just highlight that and click Save. Okay, now once we've done that, let's go ahead and go down and start our DHCP server. We will click Start. Okay, so now you have a fully functional router. You have your subnet. Within that subnet, you have DHCP range assigned. You can add hosts to that subnet. I will show you how to do that real quick. You can come up here. Let's look at our interface card for this machine. Shows here your hardware address. So let's get that's the same as your MAC address. Let's copy that MAC address. Under hosts and groups, let's go ahead and add a new host. So we'll call this Ubuntu Desktop. And now we need to leave it set as a top level domain. If you assign it within the subnet you created, which sounds logical, but if you do that, you're going to receive errors saying that the host names are global, that they're not restricted to the way that you've assigned them. So leave that at top level. Go ahead to your hardware address. That's going to be the MAC address you just copied. Put that in. And we're going to say that this machine is always going to receive .100. That's the one that we assigned in our interfaces card for this computer. So if you wanted to change lease times, which really isn't necessary on a static address, you can. Otherwise, that's pretty much all you need to put in. You can put in a host name, like let's say ubuntu.router.com. Now remember router.com, because I'm going to show you in a minute how to get this address to resolve to that host name. So let's just use ubuntu.router.com. Let's hit create. Now you see here you have a new host, which is a statically assigned address, which is outside your DHCP range. Remember, and that machine will always get that same address, and it will have this host. So let's apply changes down here. Okay, so now that's set. We have one machine statically assigned on our new router. Everything's functioning. Let's go ahead and come down here and configure our firewall, because that's pretty important, especially if you're in a live environment. If you're configuring this on a virtual environment or on a separate subnet that's not you know, connected, or if there's another firewall in front of this router, then you're okay. But otherwise, let's go to configure our Linux firewall. So what we want to select here is to do a network address translation on our external interface, which is ETH0. That's the public facing interface. So we want to also enable firewall at boot time. We'll check this and then just click set up firewall. Okay, so now that we've got our firewall set up, we want to go up here to packet filtering. That's the IP table we want to show. Now we're going to set our default action for incoming packets. That's packets that are directly addressed to our router. We're going to set our default action to drop and then click this button here to set default action. Also for forwarded packets, any packets passing through our router, we're also going to tell it to drop all those packets. Now that sounds crazy, I know, but we're going to set this up to where only the ones that need to be coming through or into this router are the ones that are allowed. So we'll come here to our incoming packets and we're going to add a rule. Now be sure you add them in this order because that's very important. iptables reads rules in order. So if you put something out of order, it may get dropped before it actually gets to the rule that it needs to pass traffic. So we're going to go ahead and accept all incoming on interface, which is equal to our loopback device. So that's all we need for this rule. Click create. We're going to add a new rule. We're going to accept on incoming interface ETH1, which is our LAN interface. So this is saying anything, any packet that is coming from ETH1, which would be coming from our internal network, any computers on that network, we're going to allow to come through. We'll create. Okay, now we're going to create another rule that states if the input interface is ETH1, meaning any traffic from the World Wide Web coming into our network needs to either have been related to a connection that we established from inside our network, or it needs to be an already established connection, meaning anything trying to come into our network that we didn't ask for is going to be dropped. So let's add this rule. We're going to accept if the incoming interface is ETH0, but here's the trick. Our connection state must be equal to an existing connection or related to an existing connection. So we will click create. Okay, so that's all the rules that we need for our incoming packets. Okay, so now let's come down to our forwarded packets, which are going to be very similar. Remember, default action is dropped, so we need to add a rule that states to accept if the input interface is our LAN side and our output interface, since this is traffic passing through, if our output interface is our WAN side, ETH0. And we'll click create. And then we need one more to hold true for our established and related traffic. We will accept if it's coming from the outside world, our WAN interface, and its destination is our internal network on ETH1, but we only want connection states that are equal to an existing or a related connection. So we'll highlight those two and click create. Now we will come down here. We will leave all our outgoing packets as accept, because it's under the assumption anything that is coming out of your network you meant to have coming out. Now there are some exceptions that might deal with you know, chat protocols, especially MRC or something like that, that you may want to be careful about in that rule. But for what we're setting up, these are basic rules that pretty much any router that you would go in and buy at the store, these are default rules that pretty much all routers are set with as far as allowing communication to and from the network safely. So let's go ahead and apply this configuration. Okay, so our firewall is set. Here is another good thing to do for your router. What we want to do is create the ability to log packets coming in and out that are dropped, because we want to be able to see, you know, I think it's fun to be able to see, you know, what everyone's trying to do to you, who's trying to get in on what port, and you know, all that good stuff. So let's add a chain. Let's call it logging. We'll add this new chain. You see it popped up down here. Okay, so here is what we want to do with that rule. We'll come up here and we'll say we're going to add a new rule. Okay, now it's going to run the chain that we just created if the input interface is ETH0. That's our WAN side. Okay, so we'll go ahead and create that rule. So now it's saying jump to chain logging if the input interface is coming from the outside world. Now that's not going to log every packet coming in, and the reason is because this rule is at the bottom of all of your accept rules. So if it's loopback interface and it's an incoming packet, it's going to be allowed through. And once a packet matches a rule, it doesn't go any further. It just travels through or is dropped. So we'll go to the next rule, ETH1. If that's the incoming interface, it's going to slide on through. If it's coming from the outside world and it's related or established, it's coming on through. But if it doesn't match one of those three rules that you established, it's going to jump to our chain, which is for logging. So it's going to jump down here to our logging chain. So now we need to establish a rule for our logging chain. So let's come down here and we're going to add a rule, and we're going to say if the input interface is ETH0, which is the outside world, and we're going to say if our packet flow rate, a good standard is if it's less than 5 seconds, and if our packet burst rate is less than 10, then it's going to log that packet. Okay, so we'll hit create. So now this is going to excuse me, I'm sorry, we needed to check log packet up here. So be sure you check log packet if the incoming interface is ETH0, and then define your packet flow rate and your burst rate. This just prevents your log files from being piled up if somebody's nailing your server trying to get in. It will just only keep a certain amount of those packets logged. So now we'll click save. Okay, that looks better. So if these rules don't pass, it's going to jump to our logging chain, and this tells it if it's coming in that interface to log the packets at this rate. Anything else that's not logged or that is logged, we want to drop. So let's add one more rule, and we're going to say to drop if our incoming interface is ETH0. So anything not logged coming in through that is going to be dropped automatically. Since logging doesn't pass traffic, it just logs. Anything basically that doesn't match these rules will be logged and then dropped. So let's apply that configuration. Now that is a pretty solid firewall setup. You can get into NAT. You already have masquerading. That's assigned with your IPv forwarding. That will allow any internal addresses to be translated to your outside world, so you get communication on all your machines. But you can also assign pre-routing packets along with forwarding. That's a whole nother situation to get into when, say, you have a mail server or a web server running. If you don't want to demilitarize that zone, you can create forwarding of packets and translate that address to an internal address to where somebody accesses your web server, it's going to go to your web server and not just spin around looking for an address. So, but that's something a little more complex for this tutorial. But okay, so we have our DHCP server set up. We've assigned a static address for a machine on that router. We have our DHCP range assigned. We have our Linux firewall set up, configured, our rules added. We have our logging set up for our rules, and I will show you where you can look at those logs. If you go up here to System, go to System Logs, and you'll come down here to Output of D messages. That's your kernel messages. Click on View, and you will see here it is already starting to log packets. It's already blocking. That's a good sign. It's doing its job. So it shows you here source address. That would be the IP address of your WAN. It's coming into destination. It'll show you what source port, what destination port. Since this is on a virtual machine, it's just showing 137, 138. Those are for shares, stuff like that. But anyway, that's where you can view your logs. You can also take a look at system logs, see if you have any errors, anything going on, kernel logs. Also, this is a good one that I look at quite often, is your authentication log. It shows who all has been logging into your server. So, and you can change how many lines it shows, so you can go through and see who all's been logging in at what time, what IP address logged into your server, all that good stuff. So logs is something you'll want to take a look at. Now keep in mind, if you don't have a real big hard drive on your server, your log files will probably fill up eventually, so you might want to clear out all your zipped log files that have been stored and pushed back. But anyway, so now that we've got all that working, we're pretty much good to go. Bind DNS is something else I'd like to get into. Probably do that in another tutorial at another time. It's we're already at close to about an hour now, so I think that's a good bit to go over in one session. You've already got your router, you've got your Ubuntu Server 14.04 installed, you have Webmin and all the packages installed, you have your interfaces, ETH0 and ETH1, both working as your WAN and LAN interface. Your DHCP server, everything is set up, your firewall's configured, you have a fully functional router. As long as you leave the DNS server At its default settings, everything should function normally. You shouldn't have any problems. Uh, it's good for setting up host name resolution, especially if you're setting up Ubuntu Server as a domain controller, or if you just simply want to have host names for your local machines. But I'll try to make another video to cover that. Um, but I hope everybody's able to get their router up and running. I think it's a lot more powerful machine than what you can buy in the store. It's a lot more configurable and a lot more secure. You have a lot of control over what comes in and out of your network. But just play around with Webmin. There's a lot of good services in there that you can use. There's also many other, you can set up web servers, proxy servers, LDAP, there's mail servers, postfix, just tons of stuff, Samba. You've got total control over your server. But like I said before, I wouldn't recommend using this server for anything other than your router, but you know, that's your choice. That's up to you. Just be sure and look into how to secure everything properly if you do. But hopefully that helps some people out. And I wish you luck and happy routing.